Right, okay, hi all. Basically over the weekend I installed Carl's T-shaped heating block and threaded thermal barriers and the dual cooling block on the 2X replicator. Main reason for the upgrade was, I don't know whether you want to see it as an upgrade or a downgrade, because apparently the first replicator series had this setup of the threaded thermal barrier, which basically helps stop air printing because it dissipates the heat through the thermal barrier a lot more efficiently. So anyway, Coles made these custom aluminium upgrades. They'll fit a stock replicator 2 and 2X, and basically over the weekend I fitted them. So with all things supplied by Carl, they very well documented, clearly illustrated, with instructions that you can download from his website. So basically in the kit you get, zoom in a bit, oops. So in the kit, this is what you get in the kit. You get the two nuts for the top, the cooling block. You can order these parts individually. What you don't get is the nozzles, and what else don't you get? A custom spacer, which I'll go into a little bit more detail later on. So yeah, I followed the instructions. I deviated slightly in areas, perhaps going over the top on some things, but I'll go through that as I go through the installation. So the instructions are well written, very clear, no problems with that. So what I've got on my replicator at the moment, that's not stock, before I go any further, is I've got Carl's Alu-Dual dual. So this is just a replacement, a straight swap out for the plastic one supplied with the stock unit. Now, reason for changing this or upgrading this is at higher temperatures. There's reports that this actually flexes or distorts with temperature. For example, if you're printing nylon or something hot. I haven't experienced it, but I've read about it on the forums. So this is one of the items I've upgraded already. That's already part of the upgrade. And the other upgrade is Dave's 3-in-1 extruder upgrade, and that's suitable for the Replicator 1, 2, and 3X series, which is these. If I find a picture for you of it installed. Okay, here you see it installed on my 2X. So you got the left and right. I think this was the sort of Mark 1 version that Dave did, and it's got a spacer that you need to fit on the right hand side. I think if you order them now, they both come the same size, so you don't need the spacer. It didn't affect the installation of the new heating blocks in the cooling bar. This is the stock cooling bar that comes with the Makerbot Replicator 2X, and this is Carl's dual aluminium carriage. Like I said, the aluminium carriage adds a bit more stiffness to the carriage, and it's not going to distort when we're printing hot at high temperatures. I don't know whether you can just make through here. Let me zoom in. Okay, here you can see how the difference between the two thermal, you can just barely see it, but basically the 2X has a setup where the thermal tube is smooth, it's just clamped in place. There's very little surface contact with the cooling block, which a lot of people believe is the reason why it's difficult to print PLA without the filament jamming, or the heat creeping up the thermal block past the break. and then the filament jamming in this area of the thermal block. So Carl's threaded thermal tubes obviously have a lot more contact with the cooling surface area, contact with the cooling block, and that is why it dissipates the heat a lot more. Right, so that's what we've got at the moment. So look at the installation. Okay, so the first thing I set about doing was actually finding out what thickness spaces I need. I did this by borrowing two of the fan bolts and bolting the cooling block on, and then getting a straight piece of PLA and running it through and just eyeballing it. And you can actually do the thermal barriers, it comes up right close, and you can run it up and down, just make sure it's absolutely bang on, and you just shim it out until you get it absolutely spot on. So once I've basically done that, then I'd actually measure the thickness of the shim. Now, if your original setup is set up correctly and your alignment's all good, then the left and right spacing should be exactly the same. So here I'm just measuring the thickness of the shim I need to make and design and print. So a bit of a pain in the butt, but I had to put it all back together, design the shim, and then print it. I've done a few different sizes, and then what I do is just sand it down on a block, sandpaper, which is the yellow stuff here, just on a flat surface, until you get it exactly where you want. Then obviously just bolt it all back together again and test fit it all. Now with the shim in, the spacer in, the bolts weren't long enough, so I just left the fan guards off. So it's a little bit of weight that we've lost as well, so I'm not too worried about that. And then again, just fit it up on the right hand side, make sure it's shimmed up. Now this shim, for whatever reason, needed a little bit more. You can just see the Kapton tape on the one edge. So yeah, it's not really a problem. I just put a couple of layers of Kapton tape there, just to bring it out so it's absolutely perfect. Again, if it was a little bit too big, we could have just sanded it down a little bit more. So yeah, it turned out really well. I'll actually upload a series of the shims onto Thingiverse, so people installing this upgrade can just download and print these shims before stripping down their printers. Just save that big process of stripping down, measuring, and then putting it all back together again. Okay, next I set up the thermal tubes in the cooling block. Now there's a couple of options for this, but in the end what I decided to do is fit the nut on the top and allow as much air gap as possible below the cooling block. I didn't want in any way to sort of impede the thermal break, which is this area here. Setting the heating blocks as low down as possible allows for the insulation that needs to go on the top. I didn't want to block the airflow through the thermal gap once the insulation was fitted. I checked the nozzles to make sure that they're both exactly the same from this sealing face to the tip of the nozzle. This is what I was shooting for, so if you ignore the fact that the heating block isn't shown, this is the sort of contact between the thermal tube and the nozzle that you'd be looking for. What I did was I set up both thermal tubes to be exactly the same height from their sealing faces, and that worked out about 10 mil. And then I just got them exactly or as close to the same height as possible. This way, when the heating blocks are added, you're almost guaranteed to have your nozzle heights very, very close to perfect. It's very difficult to get them absolutely spot on, but this way you are guaranteed to get them very close. With the heating block added to the assembly, a really good way of telling whether you've got the correct surface made between the nozzle and the thermal tube is to have a slight gap over here. This sort of guarantees that the nozzle hasn't bottomed out against the aluminium heating block rather than the thermal tube. which is what you're after. Having a slight gap almost guarantees that you're going to have a good seal. Next came insulating the heating block. Now I was in two minds whether or not to insulate it, and in the end I did. I think the majority of people believe that it should be insulated. I will add that there are a few people who are running this upgrade without insulation and aren't having any problems. I felt that the traditional ceramic tape used for insulation might be too thick and might then block the thermal break on the thermal tube. So I was really keen to keep this space open, insulate around it, but keep the space open so we can get some air flowing around that area. After a lot of research and a lot of looking around, I thought I'd give this stuff a try in the UK. It's basically used for sports cars, and it's wrapped around exhaust pipes, etc., to try and keep the temperature in the engine bay as cool as possible. I was hoping, although there's no technical dimensions on it, I was hoping it'd be thin enough just to wrap straight around the heating block, and it's quite an awkward shape, being T-shaped. So when it actually arrived, it was actually too thick. It was way too thick, but I did come up with a solution in the end. All I did was strip a long length of the insulation. It's threads, like a woven mat. We do strip off a really long length and basically bind up the heating block. The advantage of doing it is you can bind it really, really tight. I gave it about 3 layers. And then added a layer of Captain tape over it all to hold it all together, and then finally just cut out any holes required, i.e. for the nozzle and the thermal tube, the heating cylinder and the thermal couplings. Pretty easy. Just take your time, wind it on as tight as you can. I went both directions, and yeah, it's just a bit time consuming. Just take time. It's the hardest part at the end is actually cutting through it to get to your apertures for your nozzle and your thermal tube. Because this stuff, I don't know what it is. I know it's like a glass fiber or something, but it's really strong, really hard to cut. But no, it's worked really well. I'll certainly use it again. I think with my roll, I've got enough to last me a lifetime. So yeah, a couple of things just to bear in mind. What I did was I actually marked up the orientation of the heating block, so I knew which was top, which was bottom. I also set the grub screws approximately at the right heights. It's one thing you just don't want to do at the end. And then at the end, just think about what bits you need to cut out. I'm going to fast forward for a while now, and I'll catch up at the end. Okay, next what I did was I loosely assembled everything and just did a double check at the end. So just loosely thread on the cooling block, the heating block with the nozzle in. If it's still loose once it's all connected, you just need to adjust it. Just undo the nozzle, swing it round and do it up again. What you're looking for is a tight fit. And remember, we're looking for that gap between the nozzle and the heating block. That tells us that the correct seal is being made against the thermal tube. Once we're happy with that, securely hold the heating blocks. I just used a adjustable wrench. So take your time with this because you don't want to strip your threads. Remember, the aluminium, the block is only aluminium, so if you go heavy-handed, you will strip your threads. So all I did was just nip it up until I felt that it was secure, really. As you're going along, just take your time. In Carl's instructions, he actually advises tightening it here and then also tightening it with the once it's all hot. I didn't do the second bit because I found there weren't any leaks anyway. So it's been running fine, just nipped up like this. But I expect if you did sensibly, what you want to do is hook this up and heat it all up and then just nip it up again. But no, I find it's all worked. Again, just check the nuts on the extruder side and make sure they tightened, and that's it. Next was prepping the thermocoupling wires. I followed basically Carl's instructions for this. Trimming back by 10mm, twisting them together. The only extra thing I did was to wrap some Kapton tape around them to insulate the couplers inside the heater blocks. Carl's instructions don't actually call for this, but I think it's not going to hurt. Also, I needed to, because of the insulation I'd added, I needed to just drill out the holes to 2.5mm. Next, the fun bit, just hook everything back up again. Over here you can see how I've routed the cabling. It worked out really well. I've got a red cable tie on there, which I'll remove later as I go on the way. It's quite tight in between the stepper motors. But no, that's really easy. As you can see, to remove this, it's going to be a lot easier. Removing it off the carriage will be a lot easier than the Makerbot setup because it all comes out together, including the thermocouplings and the heater. Don't know what you call them, cylinders. So once we've got that all ready to go, obviously you just screw it back down onto your carriage. Make sure everything's square, pull it up tight, nip it up. So there's plenty of clearance from the back in between the stepper motors with where the cabling's going to go. This is it all assembled, ready for bed leveling and calibrating, really. All worked out really tidy in the end. Very happy with the installation. Okay, next after leveling the plate and calibrating the nozzles, I printed the cone. I'll say calibrating the nozzles, I actually forgot to calibrate the nozzles. You know, the sort of tramming of the nozzles, and they're slightly out in the x-axis, as you'll see on the cone here. I also had to, even though with all the care taken setting up the cooling block and the thermal nozzles, etc., the thermal tubes and the nozzles, I was ever so slightly low on the left-hand side with the left extruder, so very easy fix. Just shim it up. So you just slacken the left-hand bolt holding the cooling block to the carriage, and just use whatever shims you choose. Some people use layers of Kapton tape. I use some Coke can and some layers of Kapton tape to get it absolutely perfect. So yeah, we see it printing. This was sliced in Simplify 3D, and you can see the slide offset on the the x-axis. Once I'd recalibrated, it was absolutely spot on, absolutely perfect. So the moment of truth came when I printed PLA, and this is my first full PLA print with the 2X, and I'm really thrilled with the quality that I'm achieving. Absolutely perfect. No problems with air printing or the like. As you can see, the quality is great. I'm very pleased. The vase was sliced in Simplify 3D with a 0.3mm layer height, and it's a single shell with a continuous the corkscrew feature that you get in Simplify 3D. So thanks for watching. I hope you find this useful, and I look forward to hearing how you get on with your upgrades. Thank you.